Okay, first of all, welcome for the class. The measures of dispersion are basically three. If you have been able to go through the notes, basically they are I think you have encountered them before. They are number one. They are number one, the range. Number two, standard deviation. Number three, you have the variance. So basically you have some data and you want to go further and at least give a better description of how basically the highest minus the lowest, that is the range, the standard deviation, how it will be able to look for data. That's how we do it. Now the range is very easy. We can start with the ungrouped data. Ungrouped data. Range is equal to highest. Minus lowest value. That's basically the range. The variance, number two, variance will be given by summation of x minus x bar all over n. All over n, where we know the value of x bar is what is the mean, and then x are the values, and then n, what is the total number listed. Total number listed, and the most simplest is basically the standard deviation. I call it SD, is given by the square root of variance. So that's how you calculate. So if you have variance, you have a standard deviation, because we should just be able just to look for for the square roots. Let's do an example. One example. Now, I can still be able to get the quartile range. The quartile range. And we have Q1. This one is a 25%, or a quarter of n. And then we have Q2, that is 75% of n, the same as 3 over 4. Values that are beyond the median. So the semi-interquartile range will go through the node. Semi-interquartile range is a big name. This one will be given by a half of Q3 minus Q1. Those are the interquartile range that we can be able to get for any data. So let me do one example to demonstrate this one. So you have to remember that Q1 is 25%. Sorry, this one is Q3. Q3 is 75%. Q2 is the median. We already dealt with the median. So Q2 is normally the median. So let's do an example. Calculate. We can calculate the range. The range, semi-interquartile range, and the variance, and SD. 4. Calculate all those 3, 4. This data here, number 1, and have 2, 3, 5, 7, and 8. So let's get Let's get the range. Someone wants to try the range? range? Someone who wants to try? Anyone who wants to try? If you have gone through the notes, it's very easy. Anyone who wants to try the range for that one? So I think you're getting it. The biggest minus the smallest number, or the highest minus the lowest number. So the highest number there is 8, and then you subtract 2, you did as what? 6. That one is easy. Let's now go to the semi-interquartile range. I'll get first of all Q1. So Q1, how we normally get Q1, I'll use a pen. I think I've given this example. You come to the middle. You see that number there? That is the middle of the number. So that is the median. So first of all, you must arrange your numbers in ascending or descending order. Very important. So the numbers have to be in not. I'll do another example, ascending or descending order. Now, these remaining numbers here, we shall take the median now of the remaining numbers, which is 2 and 3. So we shall be able to not the median, the average. So Q1 will be given by 2 plus 3 all over 2 is equals to what? 2.5. So you must be able to block the median. If you are able to identify the median, then you just block it, then the remaining numbers will be okay. The remaining numbers will be okay for that one. Just block the numbers and the remaining numbers will be okay. So you just have to take the average of the remaining number, or you take at least now, it's as if you're taking the median for those numbers. It is as if you are taking the median for those numbers. If you go back through I've been able to demonstrate that one for you. Now, let me see. So I've seen in the example that I gave you, I had done a mistake. It was a mistake that I had done, so I think I'll be rectifying that. I've seen a mistake that I did, but in this example, I think you'll be able to get it. So that is 2.5. That is 2.5. Now, again, now Q3 will be now given by what now? Again, 5. If 5 is our median, then we consider 7 and 8. So the number in the middle there is just 7 plus 8 because there are two numbers. We shall take the average with the same as 7.5. 7.5. So semi-interquartile range will be given by a half of 7.5 minus 2.5. 7.5 minus 2.5, that is 5. So the answer should be 2.5. If you are told the interquartile range, you remove the half to just be 5. But because of the word semi, we must be able to divide it by what? We must be able to divide it by 2. I think I'll be able to do another example. Just bear with me, and then to make this one a bit clear. Maybe now go to the variance. The variance. Now, variance, I've given you a formula. So the variance will be given by summation of x minus x bar all over n. So first of all, I'll come and get the mean. So the mean x bar will be given by 2 plus 3 plus 5 plus 7 plus 8. I divide this one by what? How many numbers are there? I think there are 5 numbers. So 2 plus 3, that is 5, 10, 10 plus 15, 25. So the mean here is what? 5. So to get now my variance now, I'll have to subtract as I square. This formula is wrong. I was supposed to square this one. Suppose that is the formula. You square. Sorry for that. You square. You're supposed to square. So the variance now That is the symbol for variance. The symbol for variance is that one. Will be given now. We take each number, we subtract the mean as we add. So the first one is 2
You are currently the only
minus 5.
person in this conference.
I'm currently the only person in the conference. Where did the people go? Are you there? Are you there?
You are currently
Class?
the only person in this conference.
Not happening. So you have said what I'll do. I will take the odds. Each digit, I subtract the mean, then I square it. I add. I take again 3 minus 5. I square it. Plus, I take 5 minus 5. I square it. Plus 7 minus 5. I square it. Plus 8 minus 5. I square it. Then all this I divide by the total number of digits, which are what? 5. So 2 minus 5, that is negative 3. When you square it, you get what? 9. 2 squared, that is 4. That is 0. That is 4. And that is what? 9. Then you divide by 5. So 9 plus 5, that is 13. 13, 26, all over 5. And the answer should be 5.2. 5.2. So that is the what? The variance. That is the variance. That is the variance. That is the variance of how you get it for that one. The variance is 5.2. So by getting the variance now, we can be able now to get the what? The SD. SD. The formula for SD is this one. Only that. The square root of variance. Same as square root of 5.2. Yeah, I'm having a calculator here. So square root of 5.2, 2.28, 2.28, and you are done with that one. So let me do another example. Number 2. We have, let's say, 4, 2, 1, another 4, can have 6, can have 5, can have 3, can have 6, can have 7, can have another 3, can have another 5. There. We looked for the range and we look for the what? For the semi-interquarter range. So first of all, I'll arrange the numbers in ascending order. Ascending order. So I'll have the least one is 1, second one is 2, then I have 3, and I have another 3, I have a 4, and I have another 4, I have 5, and another 5, then I have a 6 and a 7. So if I arrange in ascending order, the range is easy to see. So the range, someone can try the range. Someone can try the range. Someone try the range for that one. I've arranged the numbers in ascending order. The range. Someone to try the range. But then you can be talking if you prefer. You don't have to be typing. As long as you mute your mic later onwards, you can be talking. Oh, so I've seen the answers almost the same as the other one. That is 7 minus 1, 7, 6. Now, for the semi-interquartile range, first of all, I will identify where the median is. So the median is here. So the median is, these are 10 numbers. So the median will be between what? The medians are 2, if I'm not wrong, those two numbers. That is where the median is. First of all, identify where the median is. After identifying the median, we are sure that the median will fall under here. So the median is falling where? Where there is the purple, it is falling, sorry, the red color there, it is falling there. That is the division of the two numbers. Those are the division of the two numbers, the one that I've done in purple, reddish. So that is the division of the two numbers. If I put there, I've been able to divide the numbers into two equal halves. So remember that the first example, the numbers were easy because the numbers were odd. The numbers were odd numbers, there were only 5 numbers. So the median was a number, but this one, it is in the middle. So identify first of all where the median will fall. It is falling in the middle. Now you consider these numbers here. Now consider these numbers here. Now I want to do Q1. Consider these numbers here. You consider these numbers here. So Q1. So Q1 is falling on their quarter, so it is falling under here. So consider these numbers on the left hand side. Can someone give me the median for that one, for those numbers? 1, 2, 3, 3, 4. Can someone give me the median for those numbers? You give me the median for those numbers, it will be out. It will be a Q1. It will be a Q1. So I've taken the numbers on the left hand side, so I want the median for these numbers. Someone to try the median for those numbers? The median for those numbers. 1, 2, 3, 3, 4. Now divided into two halves. 1, 2, 3, 4, 5, 1, 2. So we have 5 numbers and we have 5 numbers. So Q1 will lie where? On their quarter. So their quarter is at the beginning. Then Q3 will fall now on the right hand side. So what is the median for these numbers? I've seen only one answer. I want another answer. So where the median basically is the number in the middle, in short. Number in the middle. So only one answer. 1, 2, 3, 3. We did the median last time. Let me check some answers. Mercy were 2.25. How? Okay, I've gotten 3 answers. I think I can work with those ones. Let us see. So the median, so that one will go, that one will go, that one will go, that one will go. So this one now. So this one becomes my Q1. So 3 becomes my Q1. Only that. Now to get Q3, I'll take the other numbers. Q3 now will be the numbers on the right. So we have 4, 5, 5, 6, and 7. Now someone try to give me the median for that one. The median for that one, or basically the number in the middle. Give me the number in the middle for that one. I've gotten one answer. Okay, at least now you're getting it now. So this one, that one will go with that one and go with that one. So this one becomes my Q3. Simple as that. So the numbers I'm circling here, this one here, this one is my Q1, this one is my Q3, the one that are in blue. So I can easily be able to come and calculate the semi-interquartile range. So semi-interquartile range will be given by half Q3, always the bigger number minus the smaller number. Then will be half of the other one was what? The other one was 3. 5 minus 3. The answer will be what? 1. So that is the semi-interquartile range. The semi-interquartile range. 5 minus 3, then half of that one. So we are done. So let's go now to the variance now. Let's go to the variance. 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 Is given by that one squared. We given the formula is this one, x minus x bar summation squared all about n. First of all, I'll get the mean, which is the x bar. So these are the numbers that I need to add. They are here. Let me confirm the numbers: 1, 2, 3, 3, 4, 4, 5, 5, 6, 7. Okay. Let's see what we are getting there. 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6 plus 7 divided by the total number of numbers. There are 10 of them. Can someone give me the value of that if you have done it? The mean for that one? Anybody who had done it? None. Okay. If you add those numbers, I think, let me see on my calc. I think I'm supposed to get 40. 1 plus 2 plus 6 plus 8 plus 10 plus 13. Yes, 40. So you get 40 all over 10 is the same as 4. So that is the mean. Now to get the variance, I'll take each number, every number that is there. So this one will be given, I take every number, I subtract the mean as a square. So the first digit is 1 minus 4, I square it, then I take plus 2 minus 4, I square it, plus 3 minus 4, I square it, plus 3 minus 4, I square it, plus 4 minus 4, I square it. Is a lengthy one. 4 minus 4 I squared, 5 minus 5 I squared, and 5 minus 5 I squared, plus 6 minus 5 I squared, 7 minus 5, sorry, 7 minus 4. I think I love 5 so much. This one is 4. There's a mistake there. 6 minus 4. Use. So here 5 minus 4 minus 4 minus 4, 7 minus 4 I squared. The whole of these one will be under what? 10. Divide all that by 10. So the first one I'm getting it as what? That is 1 minus 4. That is negative 3. When you square it, you get 9. You can't get a negative answer here. Plus 4. This one is supposed to be 4. 4. Sorry for that. So I'll get it as 1 plus 1 plus 0 plus 0 plus 1 plus 1. That is 2 squared, that is 4. And then 7, that is 3, which is 9. All about all over 10. If I do this one correctly, 9 plus 4 plus 1 plus 1 plus 2 plus 4 plus 9. 30. Making us 30 all over 10. The answer will be 3. Now, SD is easy. SD is easy. SD, that is standard. Deviation. So this one will be given by that. Square root of variance, square root of 3. It should be the same as 1.732. Anyone with a question so far? Anyone with a question? If you don't have a question, you can tell me to proceed. You can tell me to proceed. We move now to group data. Anyone with a question? No question, I can be able to proceed. Okay. So one person says, I proceed. Group data, group data. Okay, let me proceed. At least I've gotten. So for group data, this is the data that I want us to work with. We have a class here. Let me put it in landscape. This I can able to do a lot. Notation, landscape. So the class our frequency, and I have 10 to 14, 15 to 19, 20 to 24, 25 to 29, and then 30 to 34. The simple data. And for this one, you can be able to have the odds. You can be able to have, let's say, 10. Be able to have it as 8. This one you can be able to have as 12. Then you can be able to have it as 15. You can be able to have it as 25. That's okay. Simple data for that one. So I'll go back to the definitions. You have them. Will not really change. For the variance, a group data, variance will be given by summation. There are two formulas. There's this one, all over summation of f. That's the first formula. If I expand this formula, I can still be able to have another formula. This one is summation. If I expand that one, also there's an f here. So it can be given by summation of fx squared all over summation f minus the x bar squared. So if you expand that one, it will still be able to give you the same as that one. That is the formula. So you can, if you want to use the first formula, no problem. If you want to use the second one, I think it will not be wrong. If you want to use any of the formulas, I'm seeing these values may be so big. Let me just change something just to suit me, but do not have any. Seeing these values are so big, I'm able to reduce these two. Reduce those two. Let me have that one like that. Just to make my work a bit easier. But it will not have any difference on the calculation. So we have 10, 12, 14, 6, and 8. So on the standard deviation, again, I'll not quote the formula because it is easy. The standard deviation, you just do what? You just do what? You just get the square root of variance. Now, Q3 and Q1 are a bit different for this one. You remember the formula for median? Q3 will be given by L, the formula for median. For median, we had a half n. So Q3, we shall have 3/4 n minus the cumulative frequency over the total frequency times L. That is the difference. And Q2 will be given by L plus 3 over, now a quarter n. 25% is a quarter n, a quarter n, again minus the cumulative frequency all over the frequency at Q3 times, one is wrong, it's not times L but times W, times W times W times W. These formulas we encountered last week, and I'll be able to demonstrate on the table how you calculate this one. But remember, Q3 is 3/4 of n, and Q2, sorry, this one is Q1. Sorry for that, Q1. Q1 is a quarter of n. So I'll start first of all with the variance for this one. I'll start with the variance, then we move now to the other ones because the variance is easy. Let me start with the variance. So we said what? We arrange our data in the form of a table. We'll have here class. Then we shall have our x. Our x was the midpoint, remember? And I'll have my frequency. Then I will need this one here. Fx squared. I want to use this formula. Let me tell you the formula that I want to use between these two. The one that I love, but you can use any. I will use this formula I'm marking in yellow. That is the formula I want to use, that one. After I get the mean, it will become much easier. So how do I get the mean? The mean is easy. If I want to get the mean, I'll have to get fx. I'll have to get fx. So that is the formula I want to use. The formula I want to use. So I need fx and fx squared. Why fx? I want fx because of the mean. After I do that, I'll do the fx squared. And then remember, I need the what? The semi-recurrent. So I'll do the cumulative frequency here at the end. So those are the number of columns you need if you want to do this one. And I have that one there, that one there, that one there, that one there, that one there. This one was 10, 14. This one was 15 to 19, 20 to 24, 25 to 29, and then 30 to 34. Can someone remind us how you are getting the X? Can someone, the first one? Let me, in yellow, let me put this one here. What is the entry there? In yellow there. How are you getting that value there? The X, we did that one in the previous class. How are you getting the X? There in yellow, the first entry. Bonio Hendrix, no. No, 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 no. I've refused. I have refused. Someone else to try? How you are getting that entry? Yes, it is addition. You don't subtract. When you subtract, you'll get a different value, not get the midpoint. You want the midpoint of 10 and 14, a number that is in between that one. So we shall add these two. That is 10. You guys have already forgotten. Quickly. That's fast. You say it is 10 plus 14. You divide by 2. You get it as what? 12. So if you do the rest here, you'll get 17. Here you'll get what? 22. This one you'll get 27. And this one you shall get 32. The frequency, I'll go back. The frequency you are given, so you don't calculate. The frequency was 10, 12, 14, 6, 8. 10, 12, 14, 6, and 8. So 10, 14, 6, and 8. So first of all, I'll calculate the mean. So fx, this one is 120. If you multiply, use a different one. The first one I'm getting is at 120. Second one, 17 times 12. 17 times 12. 204. 22 times 14. 8. 27 times 6. 162. Then 32 times 8. 256. But those are the value of f of x. Then I'll get the value of f of x squared. So I'll square the x and then multiply by 10. 1440. 17 squared times 12. 6468. The other one is 22 squared times 14. 67. 76. Then 27 squared times 6. 4374. Then I have 32 squared times 8. 81. 92. Then I'll get the cumulative frequency from the frequency here. The cumulative frequency there. I'll get the cumulative frequency. So I'll input the first digit here, which is 10. I add 12, I get what? 22. Plus I add 14. 22 plus 14, I get 36. 36, I add 6, I get 42. Then 42, I add 8, I get what? I get 50. This value should correspond with the total frequency. The total frequency here is supposed to be 50 here. Now I'll add x 120 plus 204 plus 308 plus 162 plus 256. Here I'm getting as 1050. Then I add the final one, 1440 plus 34, 68 plus 67, 76 plus 43, 74 plus 81 plus 81, 92. I'm getting it as 24, 24 to 50. So on the table, if you want to do, you'll have to have all those. F of x, fx squared, and then the cumulative frequency. And I believe if you go through the notes that I gave you, on the table, that's what I have. I've used the same formula. So from there now, it is easy now. So let's go to variance first of all. Variance. So variance is this symbol squared will be given by summation of fx all over summation of f all over what? Summation of fx. This one is squared all over summation of f. Remember this one here, pen, this one here. The whole of this one here, this one is the same as the what? The mean. That is the same as the mean. If you have been following, that is the same as the mean. So let's do this one. Let's get what we want. So so this one will be given by 24 to 50. Our total frequency was 50 minus 1050, 1050. Again, the total frequency is what? 50. Do that one correctly. 24 to 50. And remember, this one is something I forgot. This one was squared. So this one is always squared. So this one is always squared. So if I do that one correctly, 24 to 50 divided by 50. When I'm getting it as what? 485. Then I get the mean, 1050 divided by 50. Then I square it. I'm getting 441 minus 485. So yeah, I'm getting here 44. So the what? The SD. This one is the square root of variance. The same as the square root of 44. Which I should be getting as 6.62. 6.63 final answer. So I believe this one, when you have a formula, it is much easy. But remember, when you're subtracting, you must square the mean. Always square the mean. Always square the mean when you're subtracting. Always square the mean when you're subtracting. So anyone on a question on variance there, I can be able to address it, or you can be able to tell me to proceed. Typing error. Oh, Mbonyo index. So anyone, you can tell me to proceed, or I repeat somewhere. How did I work out the fx squared? Okay, so that is the first question. Okay, let's go back how I worked out the fx squared. This is the table I have. How did I work the fx squared? I took this 12, I squared it. When you square 12, what do you get? I'm doing the first entry. So 12 times 12. I get 144. Then the 144 I multiply with the f, which is 10 times 10. I'll get 1440. Or you can come and take the frequency, which is 10, and then you multiply by x squared. Our x, remember, is our midpoint. It is our midpoint. So 12 squared. 12 squared is the same as 144. You'll get 1440. The second entry here, this entry here, the entry I'm pointing, this one here, this one is my f. This one is my f here. You can be able to see is 12, and then this other value is 17. So I'm multiplying this 12, multiply that 12 times 17 squared. I'll get now 3468. That's how I'm doing it. I'm squaring the x. I'm just squaring the x. You take the f and then you multiply with x squared. Sophia, is that one clear? Is that one clear how you're getting it? Sophia, I've taken the f as 12, I've taken the x as 17, and then I've squared it. You must square the x is the one that is squared. Only the x is the one that is squared. Any other question, or I proceed now to Q1 and Q3? You can tell me to proceed. Okay, so let me, meaning that x is the only one that is 2. Meaning that x is the only one that, yes, x is the only one that is squared. The f is not squared. Okay, the f is the only one that is squared. Yes, this one here. The f is the only one that is squared. Sorry, the x is the only one that is, this one is the only one that is squared. The one that I've marked with the purple there is the only one that is squared. If I'd written something like this one, now brackets are very important, I'll have a different outcome. Now this one, check this one out. That one means that f, this one is the same as f is squared and x is squared. But what I have here, there's no brackets. So it's only the x that is squared. Only the x is squared. No, the f is not squared. The f is not squared. Okay. Have I answered your question, Sophia? It's only the x that is squared. Okay, yes. It's only the x that is squared. Let's now go now to the cumulative frequency to assist us to get Q0, to get Q1. So remember the formula for median. The notes are there. You can be able to have them. You have the video. You can be able to get. So we say that Q1 is always a quarter of n. So a quarter of n here is what? Our n is 50, remember? So our quarter of that one, our total frequency was 50. So a quarter of that 50 divided by 4 is 12.5. It's 12.5. Then I'll have Q3. I want to do them at once. Q3 is 3/4 of n, which is a quarter of, sorry, 3/4 of 50. 3/4 of 50 3/4 of 50, I'm getting it as 37.5. So let's go back to the table on the cumulative frequency and trace where 12.5 will fall and where that 37.5 will fall. I'll start with 12.5. 12.5 will fall where? Go to the cumulative frequency. Can someone assist me there? On the cumulative frequency, 12.5 will fall between which digits? We did this example last week. So 12.5, I'm asking, will fall under which digits there on the cumulative frequency? Someone has gotten it. 15 and 19. Okay, that is for the frequency, correct. But now on the cumulative frequency here, that's why I was asking. But you are still correct, Warren. That is where it will fall. So I can easily use another pen to be able to demonstrate this. Can I use red? So this is where, in between there, that is where Q1 is falling. Q2 was 37.5, so 37.5 is falling there. That is Q3. That is where it is falling. So you remember the formula for for the median. So I'll start with Q1. So Q1, I will use the frequency for Q1. Remember, someone has given us it is 15 to 19. It is falling under that class. So what is the lower class boundary for this one? So they will fall under here. Let me use the pen for the sake of revision. So the first one, this is the class that we are concerned with here. This is the class that we are concerned with for Q1. Then for Q3, this is the class that I'm concerned with. These are the two classes that I'm concerned with. So for Q1 is 15 to 19, and Q3 is 25 to 29. So what is the lower class boundary of 15 to 19? That is easy. The lower class boundary for that one, is easy, 15 to 19. So this one is falling under that class. So Q1. So Q1 is falling under that. If you remember the notes for median, it is very easy. So Q1, we have said it is falling which class? 15 to 19. And then Q3, we shall give the class later. So what is the lower class boundary here? It is 14.5. Then minus, plus. Then we take a quarter n. Our quarter n was 12.5. We subtract the cumulative frequency, which is 10, and then we come here to the frequency of that class, this class that I've marked here. What is the frequency? So I've taken 12.5, where Q1 is falling. Q1 is 12.5. I've subtracted the cumulative frequency 10, and then I come to the frequency. The frequency for this class that I've marked in what? In blue. The frequency there is what? The frequency is 12. The frequency is 12. Here. Frequency is 12. I'll go back and divide by that frequency. And then the whole of that one, I multiply with the class width. So I go back, what is the class width here? Can someone try? What is the class width for these ones? What is the class width? What is the class width? Sawa, if I've gotten one answer, that's okay. If you have any questions, I think Warren is getting it, so you can see him. You'll be able to see him. So it is 5. I'll tell you how you have gotten the 5. When this one, when you do it, is 14.5 plus, that is 2.5 times 5 divided by 12. I'm getting a very weird answer. 12.5 minus 10 divided by 12, then times 1. It's correct. 1.042. And then plus 14.5. We're getting 15.542. That's where we have. That is the Q1. So go back again now. You see where our Q3 is falling. So a person may ask, how did I get the 5? It is easy. For the class width, you take the upper class boundary, you subtract the lower class boundary. Or I said, are you seeing now the X here? For you to move from one to the other one, for you to move from 12 to 17, from 17 to 22, from 22 to 27, from 27 to 32, they have a constant of 5. They have a constant of 5. So let's go to Q3. So Q3, the class is 25 to 29. So the lower class boundary is what? I'll take two things. So the frequency is 6. We can be able to agree. Let me circle them. The frequency is 6. Here the frequency is here. The frequency is 6. There the frequency is 6. The lower class boundary for this one, it shall be 24.5. 24.5. Then I'll have to subtract what? The cumulative frequency, which is 36 here. I'll have to subtract that one. So This is what I'll get now for Q3. Q3. So Q3. So Q3. I'll have, you have said it is what, 24.5 work class boundary. Then I'll have the 3/4 N, and then I subtract 36. The total frequency there, sorry, the frequency at that class was 6, and then I multiply here by 5. Let me go and confirm again. U3. So let me go and confirm the, because now for me I have to always confirm because the table I cannot be able to see it. Yes, 24.5, that is the lower class boundary. The frequency is 6, and then we subtract here. We want to know the steps there, so we subtract 36. We always subtract the frequency of 36. The cumulative frequency of 36. If we do that one, that is 37.5 minus 36 divided by 6 times 5. 1.25 plus 24.5 minus 24.5. I'm getting is at 23.25. Now let's now complete now. So semi-interquartile range will be given by a half of 23, and that is Q3, minus Q1, which is 15.542. And if you do that one correctly, minus 15.542. I divided them by 2. I'm getting as 3.854. So class, if you can be able to understand how you are getting the median, I've multiplied with the class width. I have mass area. I have multiplied 37.5 minus 36. I got it as 1.5. We are wrong. Then I divided by 6. Then I multiplied by 5. I'm getting 1.25. Okay, where are we wrong? Confirm to me where we are wrong. That's what I'm saying. And in Q3, I want you to tell me where I'm wrong. Oh, sorry. Yeah, I've seen. I subtracted instead of adding. Oh, so I subtracted instead of adding 24.5 plus 1.25. Thank you for the correction. 25.75. I subtracted instead of adding. Okay, so yes. But my question is, are you understanding what I'm doing? The arithmetic, we can always be able to argue about that, the addition and the subtraction. That one has no problem. But are you getting what we are doing? That is the most important thing. This one is 25.75. Thank you for that. 25.75 minus 15.542. Then it divided 1 by 2, 5.104. Okay, sorry for that. I had subtracted instead of adding. Is that one okay now? Okay, so 27.6. Yes, I have seen the mistake I had done. So we had said if you get the median correctly, calculate the median. We had done so many examples on the median, so you can be able to hack it out. The variance. And the variance was easy. I think I showed you how to